Greetings of the day, dear students. In this video, we are going to discuss about the PNP and NPN junction transistor. We will discuss what are the different bipolar junction transistors we are having, BJTs, like PNP transistor and NPN transistor. What is its symbol, right? And what do we mean by the different terminals we are having, like emitter, base, collector, and what is the functionality of each one. And also we will discuss the working of NPN transistor along with its block diagram and circuit symbol, and also working of PNP transistor in this video. So dear students, bipolar junction transistor, it is basically a three-layer semiconductor device. It is going to consist of either two N and one P-type layers or two P and one N-type layers of material, right? Or simply to say, it is just two diodes connected back to back. If you recollect the previous basics of the diode which is nothing but a formed with the help of a PN junction diode, right? Similarly here, the transistor, we can consider it as two diodes connected back to back. So how do you understand that? There will be two junctions formed. One is due to the PN junction and another one is due to the NP junction. Two junctions will be formed, right? We are having two types of BJTs. One is the PNP transistor and another one is the NPN transistor. In this combination, in PNP, emitter will be the E for emitter, B for base, and C for collector. E indicates emitter, B is the base terminal of the transistor, B is the base, and C indicates the collector terminal of the transistor. Right? So here, now the junction that is formed between the emitter and base, that junction is called emitter base junction, and the junction formed between the base and collector, between the base and collector is to be called as collector base junction. Now what will be the function of an emitter? If we observe it with respect to if we consider PNP transistor, in emitter, the majority charge carriers are holes, P for positive. P indicates positive, right? From our diode basics, those are nothing but the holes. N indicates negative, right? Nothing but the electrons. Now in PNP transistor, emitter is positive, so the majority charge carriers are holes. In N region, the majority charge carriers are electrons and the minority charge carriers are holes. With respect to the collector, here it is connected to the P, positive, holes. The majority charge carriers are holes and the minority charge carriers are electrons, if it is PNP transistor. Similarly, with respect to NPN transistor, in emitter, the majority charge carriers are electrons. In base, the majority charge carriers are P, holes. In collector, the majority charge carriers are electrons, N, right? So like this, depending upon the PNP or NPN, we can decide what are the majority charge carriers and what are the minority charge carriers. Now the function of this emitter, the left hand side section of the region of the transistor, obviously will be, it is heavily doped compared to the other regions, because its main function is to supply the majority charge carriers to the base. The emitter is going to supply the majority charge carriers to the base, and the collector will collect those majority charge carriers. Now base will act as an intermediate layer, right? So the base forms the middle section of the transistor, and it is very thin. It will be in the order of 10⁻⁻⁶ meters as compared to the emitter or collector, and it is very lightly doped, right? From our diode basics, doping means adding the impurities. Adding of impurities is called doping, right? So very lightly doped means impurities added are small in number. Heavily doped means impurities added are heavy in number, right? Now, what will be the function of the collector? With respect to the transistor, the right hand section of the region, section or region, and is the collector. Its main function is to collect the majority charge carriers coming from the emitter passing through the base. It is going to collect the majority charge carriers coming from the emitter through or via base, right? Now, in most of the transistors, the collector region is made physically large, right? Because its main function, it is going to dissipate much greater power. Right? So emitter emits the majority charge carriers, and the base and the collector is to collect those charge carriers. Clear? Right. Next one is the working of NPN transistor. Just like our diode, where we have used to forward bias the diode. If you recollect the basics of the diode, if it is to be forward bias, right? Anode and cathode. Anode is connected to the positive, and cathode is connected to the negative. P is connected to the P region is connected to the positive terminal, and N region is connected to the negative terminal. Then the diode is forward bias, right? So here also, if you recollect, dear students, the forward bias, as I told you earlier, we are having two junctions. Emitter base junction is to be forward bias. Emitter base junction will be forward bias, and collector base junction will be reverse bias. You can observe here. This collector base junction will be a reverse bias. So how do you understand that? In order to make it forward bias, this is emitter, this is base, and this is collector, and emitter is N region. So to make it forward bias, this will be connected to the negative terminal of the battery, and the base will be connected to the positive terminal of the battery. To make this collector base junction reverse bias, N region, N will be connected to the positive terminal of the battery, and the base will be connected to the negative terminal of the battery. Like this, what happens is, now the emitter base junction is forward bias, and the collector base junction is reverse bias, right? Now what happens during once the emitter base junction is forward bias, now the majority charge carriers will move towards the base. In NPN transistor, the majority charge carriers are electrons. Now these electrons will be pulled towards the base. Now this base will pass these electrons to the collector, right? So here the forward bias is an emitter base junction causes the electrons to move towards the base, and this constitutes the emitter current. As and when there is a movement of the electrons, it is going to result some current. That current is denoted with letter IE. Now this electrons flows towards the p-type base, and they will try to recombine with some of the holes. Already some holes are present in the base, because the base region is p-type. Because of its p-type nature, there are already some holes. Now the electrons are coming from the emitter, and some of the electrons will get combined with the holes, but still, because the base is lightly doped, still there will be some excess number of electrons coming from the emitter, and those will be passed to the collector, and those excess electrons will be passed or will be passed to the collector, right? So now these recombined electrons, because already some electrons have combined with holes in the base, some small amount of current will result. That current is called base current. I repeat again, because of the majority charge carriers coming and combining with the majority charge carriers in the base region, some small amount of current will flow. That current is called base current, right? Now the remaining electrons crosses the base region, and they will result in the collector current. Now IE, emitter current, will be equals to the I base current plus collector current. This is how the working of the NPN transistor will be. This is the symbol for NPN transistor. You have to write these three terminals like this. You have to encircle like this, and very important thing is you have to place the arrowhead like this. For NPN transistor, the arrow will be coming from base to emitter. The arrowhead direction will be from base to emitter in NPN transistor. You have to encircle like this. You have to, for example, if you are drawn like this, okay, emitter base collector, and you have to encircle like this, and you have to place the arrow. You have to place the arrow. Arrowhead will be the emitter base collector. Like this, we have to indicate. IE equal to IB plus IC. Similarly, with respect to the PNP transistor, again the same concept. Now this emitter base is to be forward bias, and this collector base junction will be reverse bias. So here this is the emitter and this is the base and this is the collector. Already emitter is P type. Making it forward bias means the P type is to be connected to the positive terminal of the battery and the base is N type. To make it forward bias, the negative N type is to be connected to the negative terminal of the battery. So here it is now forward bias. Similarly, now the base collector junction is to be reverse bias. For that sake, already the collector is P type. To make it reverse bias, it is positive P. Just make it connected to the negative terminal of the battery, and the base, which is N type negative, connected to the positive terminal of the the P is to be connected to the negative. The P is to be connected to the negative and the N is to be connected to the positive. So now this emitter base is forward bias and collector base is reverse bias. Once it is forward bias, now the majority charge carriers in the emitter will move towards the base junction. Now this here in this context, in PNP transistor, in emitter region, the majority charge carriers are holes and they will combine with some of the electrons in the base. As the base is lightly doped, right, only few number of electrons will be available for the recombination and the remaining excess holes will be collected by the collector. Now because of the combination of the holes with electrons in the base itself, some small amount of current will flow. That current is called the base current. Now because of the movement of the majority charge carriers from base to the collector, it is going to result in the collector current. It is going to result in the collector current. So here also the emitter current will be equals to the sum of the IE. Emitter current will be equal to the sum of the current, base current plus collector current. This is how it works. This is how it works. Now depending upon the modes of operation, transistor modes, operating modes can be either active mode, very important dear students, or saturation mode, or cutoff mode, right? So what happens in active mode? Simply to say, emitter base junction is forward bias and base collector is reverse bias. Base collector junction is reverse bias. If that is the connection, then it is to be called as active mode. In saturation mode, emitter base is forward bias and base collector junction is also forward bias. If you are making this collector and emitter also forward bias mode, if it is also forward bias, and this emitter base is also forward bias, then such kind of combination is to be called as saturation mode. Now other possibility is also possible. If for both the junctions are reverse bias, that is emitter base is reverse bias and also collector base junction is also reverse bias, then such kind of operation is to be called as cutoff mode. The diode can be operated in the transistor can be operated in either of these modes. One is the active mode, saturation mode, and cutoff mode. But most of the times it will be operated in the active mode. It will be operated in the active mode. that is base emitter junction will be forward bias and collector base junction will be reverse bias, right? Forward bias, reverse bias, simply to understand, dear students, if it is PNP transistor, to make it emitter base forward, P will be connected to positive, N will be connected to the negative. To make base collector reverse bias, right? Now the same base will be connected to positive terminal and the collector will be connected to the negative terminal of the battery. Once it is done, the movement of the charge carriers will happen, right? And because of that, the current will be flowing. In this entire discussion, the emitter current IE equals to IB plus IC. Emitter emits the majority charge carriers, base will act like intermediate medium, and the collector collects those emitted majority charge carriers from the emitter. Base is lightly doped, emitter is heavily doped, and the region of collector will be large because of the high. It has to collect the. It has to dissipate greater power. It has to dissipate the greater power. Because of that, it's a physically large. It will be physically larger in area compared to the emitter and base. But emitter is heavily doped. Base is lightly doped. The thickness of the base is 10 power minus 6 meters. In PNP transistor, emitter is P, N is base, and collector is P type. In NPN transistor, emitter is N type, base is P type, and collector is N type. E for emitter, B for base, and C for collector. P for positive, poles will be the majority charge carriers. N for negative, electrons will be the majority charge carriers. It is simply a two diodes connected in back to back. Right? This is what all about the BJT indicates the bipolar junction transistor. This is what all about the PN transistors. PNP and NPN junction transistor. One more point, important point. If it is NPN transistor, the arrowhead is to be from base to emitter. This is the symbol. And if it is NPN transistor, the arrow must be from emitter to base. This is very, very important. The arrow must be from emitter to base. This is the only difference. The direction of arrow will change. Remaining all will be same. Right? Thank you.